Now we're looking at solving rational equations. There are two different ways we're going to look at doing it. The first method is cross-multiplying. You're going to use this when you have two fractions that are equal to each other. So we don't have any extra terms. We just have one fraction equal to the other fraction. It's cross-multiplying just like you did. So we're going to do 9 times the quantity x plus 1. Okay, keep in mind this whole denominator is a group, so we need to leave it in parentheses. That's equal to 3 times 4x plus 5. We want to solve for x. If we run into squareds, then we're going to set it equal to 0 and factor. Always check for extraneous solutions. We'll talk about those in a minute. So we're going to distribute. Got 9x plus 9 equals 12x plus 15. Solve for x. I'm going to subtract 9x. So 9 equals 3x plus 15. Subtract 15. So we've got 3x. So we've got 3x equals negative 6. So x is equal to negative 2. Extraneous solutions are when our denominator is 0. So if we plug negative 2 into our denominators, that one is not 0. 4 times negative 2 plus 5 is not 0. So that is our answer. The second method is when we're going to use least common denominators. You're going to use this when you have more than one term on each side. So if you notice, we have a 1 minus 8 over x minus 5. So we can't cross multiply because we have this third term over here. In order to do that, really the goal is we're going to multiply every term by the entire LCD. This is going to get rid of your denominators entirely. Then we're going to distribute to combine like terms, solve for x, always factoring if we need to, and then check for extraneous solutions. The first thing we need to do is find our LCD. If there's anything to factor, make sure you factor. So we're going to factor if needed. So this first one, we don't have any squares, so we don't need to factor. So if we look at my denominators, remember this 1, we can make it a fraction, it's like 1 over 1. So the LCD, we've got 1 times, which is not going to change anything. We've got x minus 5. We also have a lone x, so we're going to put that in front. So our LCD is x times x minus 5. So we're going to multiply every single term, just the tops, by that x minus 5. So we're going to go x minus 5, x minus 5, x minus 5. What happens if we have 3x times x minus 5 divided by x, the x on top and bottom cancel out. If we have 8 times x minus 5 over x minus 5, the x minus 5's cancel out. Here we just have a 1 on bottom, so nothing really cancels. Now we want to rewrite what we have left over. So we've got 1 times x, which is just x, times x minus 5. So x times x minus 5 minus, here we just have 8 times x, so minus 8x equals 3 times x minus 5. Distribute what we have. So x squared minus 5x minus 8x equals 3x minus 15. Distributing that. Combine like terms. So we've got x squared minus 8 and 5 make 13, so minus 13x equals 3x minus 15. In order to solve this, since we have an x squared, we're going to need to factor. So we'll set equal to 0. Okay, that's only if you're factoring. Sorry, that says set equal to 0. So we'll subtract 3x. We're also going to add 15. So those will go away. 0 equals x squared minus 16x plus 15. Factor. Multiplies to be positive 15, adds to be negative 16, would be x minus 1, x minus 15. So our solutions, when we set them equal to 0, we'd have x equals positive 1 and positive 15. We want to check for extraneous solutions, so see if it makes our denominator 0. Now, I've scribbled out my denominators, but this used to be a minus 5, and that used to be an x. So if we plug 1 into any of our denominators, none of them will be 0. We plug 15 in, nothing will be 0, so we have two solutions, which would be x equals 1 and x equals 15. The last example, You notice on the last example, we've got x minus 3 as a denominator, x squared minus 9, and x plus 3. Once we see this x squared minus 9, we want to go ahead and factor this. So this will factor to x plus 3, x minus 3. Oops. So we want to look at our LCD. So looking at our LCD, least common denominator. My first denominator has an x minus 3. My second one has an x plus 3 and an x minus 3. Well, we already show the x minus 3, so we're going to do an x plus 3. My third denominator has an x plus 3, which we already have in here, so our LCD is x minus 3, x plus 3. So that means every single term, all the tops, we're going to multiply by x plus 3, x minus 3. X plus 3, x minus 3, and then x plus 3, x minus 3. Again, when you do these problems on your own notebook paper, leave yourself a lot of space. Write big. You want to clearly see what's happening. So x minus 3 and x minus 3 cancel. We're left with 6x plus 3. And we have our equal sign. X plus 3, x minus 3 cancels. X plus 3, x minus 3 cancels. Left with 8x squared. And we have our minus. Here we've got the x plus 3 and x plus 3 cancel. So we're just left with 4x times x minus 3, which now looks like a little bit simpler of a problem. We don't have any fractions happening here. So we need to distribute. We've got 6x plus 18 equals 8x squared minus 4x squared plus 12x, because negative 4 times negative 3 is positive 12. We want to combine like terms and set it equal to 0. So we've got 6x plus 18 equals 8x squared minus 4x squared is 4x squared plus 12x. We're going to subtract the 6x and to subtract the 18 because we want to move them both to the right side. So those go away. Got 0 equals 4x squared plus 6x minus 18. When we go to factor, we notice that all three terms divide by 2. So we'll have 0 equals 2x squared plus 3x minus 9. We need to go ahead and swing and divide. So multiply the first times the last. We got 2x squared plus 3x minus 18. Factor that to multiplies to be negative 18, adds to be 3. Be x plus 6, x minus 3. Don't forget, once you swing, then you have to divide by 2. So we'll divide both of these by 2. Go ahead and come up here. So when we do that, we've got 0 equals 2 in front. Then this reduces to x plus 3. This doesn't reduce, so the 2 comes in front. 2x minus 3. Okay, now we need to find our solutions. So we're looking for all the things that make x 0, all of our roots, all of our zeros. The 2 doesn't have an x, so we're going to kind of just ignore it. It's just there affecting the width. X plus 3, that would be x equals negative 3. Here we want to set this equal to 0, so 2x minus 3 equals 0. So 2x equals positive 3, x equals 3 over 2. So we've got x values of negative 3 and 3 over 2. Again, don't forget to check for extraneous solutions. So if we go in and we plug in a negative 3, our original denominators were x minus 3. We had x squared minus 9. Oops, this was a minus. And x plus 3. So if I plug in negative 3, if I plug negative 3 in for this x, negative 3 plus 3 is 0. Just by this one, we can't have it, so negative 3 is extraneous. We plug in 3 over 2, which is 1.5. 1.5 minus 3 won't be 0. 1.5 squared minus 9 is not going to be 0. And 1.5 plus 3 is not 0. So our answer is just x equals 3 over 2.